Uh, First of all, welcome all of you to this webinar. The motto of Code4X is to help you learn by doing. Okay, our motto is learning by doing, because learning by doing is not only the most effective, but is also the most effective use of your time and energy. Because when you do a month-long course or a 2 month long or 6 month long course, you go through a lot of details and very little of hands-on. In terms of the Code4X approach, the learn by doing approach, you do a project, and while doing the project, you learn rather than learning a lot of different things about that particular topic. You learn by doing, and that is what is required in the industry. That is the main theme that Code4X brings in. All right, so what are we going to do in this today's webinar? We are going to have a hands-on session on decision trees. Now, decision trees are machine learning algorithms. Okay, so what the way we are going to break down our session today is we are going to do a little bit of introduction to machine learning, and then followed by some concept on decision tree as to how decision tree is constructed, and then we are going to do the hands-on with actual Python coding. All right, so that's going to be our approach for this webinar. All right, so let's get started with some machine learning concepts. Some of you may have had some exposure to machine learning already on. I'll take names of some of the use cases that are popularly we come across in the industry as machine learning, common machine learning use cases. So let's say for email spam filtering. Now, email spam filtering, if you have followed machine learning or data science, email spam filtering is a project that is very common. Now, do you really need to do email spam filtering? Yes, you need to do email spam filtering, because it does not teach you email spam filtering, but it actually teaches you how to do text classification. So if you do a email spam filtering course or a project, then what you learn is text classification, and that is a very common technique that is used across the industry. So you will not be doing email spam filtering, but if you know the text classification techniques using different machine learning algorithms, you can do any kind of text classification in your organization. And text classification is a very common type of problem statement that organizations work on. Right. Okay. So image classification. So there are many common projects you will come across: Cyphertain dataset, or Iris flower recognition, etc., etc. Again, so those are common projects, but what you actually get to understand is is the technique of image classification or object detection, right? So when you learn these techniques, you will be able to do any kind of or solve any kind of image classification or object detection problem statements. Stock price prediction, again, you will hear about them very commonly. But if you do a stock price prediction project, and Code4X has a stock price prediction project, we have deliberately kept the common project of stock price prediction. Now, you don't actually only learn stock price prediction, but you learn how to do time series analysis. Okay, how to do time series forecasting. So if you do the stock price prediction, you will actually learn time series prediction, and using that knowledge, you can actually solve any kind of time series prediction. So these are some of the um, common scenarios, or common techniques, or common use cases of machine learning. So what is machine learning? Let us understand machine learning by a little comparison of traditional programming versus machine learning. Okay, what is traditional programming? So let's say, for instance, you are writing a program in Java or Python, or say C++. There are many languages in the industry, and you may have written programs in some of those languages. Okay, so when you write the programs, what happens? Somebody comes in and tells you that, okay, these are the things that I want to come out from the program. This is how the data is going to look like. The input data is going to look like, and these are the XYZ rules that you need to build in your program, and so that the program can transform the input data into the output data, right? So what you know at the time of starting to write that program in traditional programming is the rules that you need to implement in the program. Okay, you know the rules, right? Now in machine learning, you do not know the rules, right? What do you know then? Because if you don't know the rules, then you have to know something to create a model, right? I mean, you are solving a problem, and you are creating a machine learning model using a machine learning algorithm. So you have to know something. So you don't know the rules in machine learning kind of scenarios. You know the data. Okay. So in traditional programming, you will be given the rules to implement, but there may not be much of an input data. Okay. You are familiar with the structure of the input data, but you may not have in reality lots of input data. Okay. But in machine learning, we do not know the rules. We have the data, a lot of data, right? In machine learning, we need a lot of data to work with. So what will we do with the data? We will apply algorithm to find out relationships within the data. Okay, to find out relationships within the data, and those relationships will be found out by the machine learning algorithms by studying all the data, and those relationships are going to be encoded in your machine learning model. So the models actually contain the rules. Okay, in machine learning scenario, in problem statements where you have to apply, where you don't know the rules and you have to apply machine learning, you have the data, machine learning studies the data and creates the rules. The rules are basically relationships within the data in your training data or input data, and that relationship is encoded in the model. So that is machine learning, and that is the difference between traditional programming and machine learning. Okay, there are various types of machine learning, and this is only a subset. There are a lot of different types coming up. You have and there is a lot of terminology that I used. Machine learning is used similarly. Data science is used more or less. They mean the same thing, but additionally you have deep learning, you have neural network. All encompassing term is artificial intelligence, so that encompasses machine learning, deep learning, neural network, data science, etc., etc. Big data is a bit different. Big data is processing of large amounts of data. Normally, big data processing happens before machine learning takes over. So in an organization, there are a large amount of data that are produced, and big data technologies like AWS data engineering, like Redshift, Glue, etc., or Azure data engineering, Azure cloud data engineering like Databricks, Data Factory, etc., or for that matter, the traditional big data concept or technologies like Hadoop, Spark, etc. They process big data, and those big data are then ingested by your machine learning or data science algorithms for solving various problems. Okay, there are different types of deep learning techniques like convolutional neural network, typically used in image recognition problem, recurrent neural network, or its variant like LSTM, or even more sophisticated versions of RNN and LSTM are your BERT architectures. So BERT architectures are the ones which are actually the backbones of your ChatGPT. Okay, so ChatGPT uses as a core of its training model, it used to have various sophisticated LSTM models, long short-term memory. Those are RNN and deep learning architectures, and variants of BERT architecture from Hugging Face. They are used as a backbone of ChatGPT. All right. So these are some of the different types of algorithms available. So that's a short summary or short intro about machine learning. Now there are different algorithms available. So in to start with, I mean, when somebody starts learning machine learning, so which are the techniques or which are the algorithms will you start with? You will not start with deep learning because they are not only more sophisticated but to solve complex problems, but also is a little more complex to learn. And deep learning, learning deep learning actually requires some pre-existing knowledge about machine learning. There are other architectures available in machine learning. So deep learning or neural network, that comes a bit later. But before that, normally people start with classical algorithms, right? Classical machine learning algorithms or classical data science algorithms. Now, what are some of the classical machine learning algorithms? So we have probably heard of linear regression or logistic regression or random forest or support vector machine or naive bayes, gradient boosting, XGBoost, etc., etc. So there are quite a few different types of or different algorithms available in machine learning. All right. So those are some of the algorithms that are available within machine learning. Now, typically, there are two broad types of machine learning that we work with. When we start with classical algorithms, we typically start with solving two different types of problem statements. One is a regression type of problem statement, and the other is a classification type of problem statement. So we'll not explain everything, but let's introduce the classification type of problems that we can solve using some of the machine learning algorithms. So algorithms like logistic regression or decision trees or random forest or support vector machine, these are some of the most popular algorithms that help us solve classification problems. Now, what are some of the classification problem statements? The text classification that I was talking about, that email spam filtering. So you give the model an email and the model will be able to tell you whether it's a spam mail or it's a valid mail. Okay, it's also called ham. So that's a classification problem. Okay, say for instance disease detection. So you have got a bunch of diagnostic results for a particular patient. You have a classification model for disease detection, let's say heart disease detection created. You feed in the diagnostic results to your model, and the model will tell you whether this person has a cardiac disease or not, or let's say a cancer prediction. So you've got a bunch of diagnostic, and this is the problem statement we are going to work with today. You have a bunch of diagnostic results, and you feed it to your model, and the model will tell you whether this person has the cancer or not. So these are some of the examples of classification problem. And today's example for our hands-on workshop is going to be a classification problem to detect whether a person has got breast cancer or not, given a bunch of diagnostic results. Okay, diagnostic test results. I mean, you have pathology results, so lab tests that are done on this person, and those test results will be fed to determine whether this person has cancer or not. So that's our problem statement. So we are going to solve that problem using a very popular classification algorithm. Okay, a classical classification algorithm of machine learning called decision tree. It's a very interesting algorithm, decision tree, in the way that it, it it it's constructed. Different machine learning algorithms use different techniques to find out the relationships between the data, between the training data that is fed to it. Okay, some use statistical methods, some use various mathematical methods, some use probabilistic methods. Decision tree creates a tree of conditions. Okay, it's a very interesting way that it creates the trees. So to start with, understand that decision tree creates a tree of, or inverted tree of, conditions, and those conditions in the decision tree lead to decisions. Okay, now what is the decision? So you have heard from me the problem statement that we are going to work with. What is the decision that we need from the decision tree algorithm in our case? Anybody? You can type it in chat. What is the decision tree that we want for the cancer detection problem statement? Anyone wants to try? It's fairly easy. So I said that, no, you need to decide whether the person has cancer or not. That is the decision that you want from the model. Okay, and that is the decision that our decision tree model is going to provide. Okay, so it'll give us a decision. Okay, so this is the patient, these are the diagnostic results, and here is a decision. This person has cancer or doesn't have cancer. All right, so that's our first thing. So we are going to explain decision tree a little bit with a toy example before getting onto the cancer thing on coding. We are going to take a toy example for understanding how the decision trees, the inverted tree of conditions leading to decisions, are constructed. So our problem statement, toy problem statement name is, do you like the movie Giggle Galaxy? There is no such movie. You will not find Giggle Galaxy in Netflix. So don't search there. It's a fictitious example. What we want to know from our decision tree model is whether a person has liked the movie Giggle Galaxy. These persons have gone to watch the movie Giggle Galaxy to a theater hall, and they have come back, and we want to understand whether they have enjoyed or not. Now, there has to be some information which should be from which we should be able to determine whether they have enjoyed the movie or not, right? So what are the information that these guys are providing us? Have they eaten popcorn? None, some, a lot. Okay, so these are the three unique values in the popcorn eaten feature. So these are features. Okay, so these three are predictor features. Okay, this popcorn eaten, loves counted, and times clap. These three are the predictor features. Okay, in machine learning, the relationship building that I have mentioned in machine learning is going to be always between a predictor, a bunch of predictor features, and one target, normally one target feature. Okay, so what is our target feature? Enjoyed Giggle Galaxy, yes or no? So that's the target feature, or that's the decision from the decision tree, right? And here are the three predictor features, right? So popcorn eaten, they may have not eaten or eaten some of them. How many times these persons have laughed? 2, 8, 5, etc., etc. How many times they have clapped? Okay, now you see that there are three fields, and there can be different types of values. And for some of them it is yes, and some of them it is no. Now, can you write a program with some rules which will be able to give you the decision whether these persons have enjoyed Giggle Galaxy or not? May not be, because it's already with three fields, it's already very complex. And in realistic situations, you will probably have 50 different features in your input data set with all different hundreds of different types of combinations of values in them. And that leads to the decision in a target feature, right? So it's not possible to write a program to get to this decision. So we want a machine learning algorithm to frame a relationship between this first three features, predictor features, and the final target feature. Okay, so that is what decision tree is going to do. So you are familiar with this data. Now we go to the next one. So this is a sample, sample of how decision trees look like. Okay, so decision trees have root nodes, and see, each of these nodes is a condition. Now F1, F2, F3, F4, these are features. Okay, now which are features in our case? Popcorn eaten, loves counted, times clap, these are features. All right, so typically in a this image does not belong to Giggle Galaxy, but this is a sample decision tree image. So there will be nodes where there will be features and conditions. So you see that there is this decision tree saying if f1 less than equals to 0.45, if it is true, then you come to this condition, and then based on true or false of this condition, you take decision A or decision B. What is the decision A or decision B in our case? Like the movie or not like the movie, yes or no, right? So that's decision A. So you see that there is decision A. So this is a binary classification that is happening here. So in our case also, it's a binary classification. So you have two values, so it's a binary classification that is happening. All right, so you Understand the construct. There are features and conditions in each of the nodes in the decision tree. So this is how it looks like. And if this decisions or these conditions fulfill, not fulfill, based on that, your data will traverse like this and then get to the decisions. $1 million question now. How do I find out which is going to be the feature and what condition will I put in my root node? Do I know from looking at this data what is going to be the condition, whether I'm going to take in popcorn, taken eaten, yes or no, or none or some, or do I take loves counted greater than equals to 3 or greater than equals to 4, or do I take times clapped less than equals to 4 or whatever? Okay, do I know that from this data? There is absolutely no way to know. You cannot realistically find out those features and conditions based on which you are going to create the decision tree, right? You cannot. So somebody has to do it. Who is going to do it? Your algorithm. Decision tree algorithm itself finds out which conditions are going to be taken, which feature, what value, what condition is going to be determined by your decision tree. Okay, so how does it do that? So then get back to our Giggle Galaxy example. So how many records do we have? We have a total record of 10. Now I am going to randomly pick up one feature and randomly going to create a condition saying loves counted greater than equals to 3. And that is exactly what decision tree is going to do. Decision tree is going to start off by picking up a feature randomly from your predictor features. Okay, these are all predictor features, right? It is going to pick up a feature randomly from the list of features, and it is going to pick up a condition randomly, and it's going to start creating the tree. Okay, but decision tree does not know whether that is the right condition to start with or not, because you have to be right in picking the right condition. Now, on what basis decision tree finds out whether that condition it has taken is the right condition or not? Okay, it has to know that, right? So it has started a process by picking up a feature and a condition at random, but it has to know whether this is the right condition. Okay, so let's work with this random condition that we have created. So loves counted greater than 3. If you look at the data, you can find out the information here. Okay, and by taking that, if the condition is yes, satisfied, then I get 8 records, and not satisfied, I get 2 records. Okay, so this is valid because I have taken that count from this data. All right, so I've got 8 records here and I've got 2 records here. 8 records satisfying this condition, 2 records satisfying this condition, not satisfying this condition. Now, what is enjoyed? Enjoyed is our target feature. Okay, that is a decision that I have to take through this decision tree. So in 8 records, if I count, I've got 5 yeses against enjoyed and 3 no's against enjoyed. And I have got 0 yeses and 2 no's in here. Okay, so what do you want? So from here, you see that notice the difference between these two. Here is a mixture of 2 classes. Okay, so we are doing classification and we are doing a binary classification. Here is a node where you have a mixture of records belonging to 2 different classes, both yes and no. And here is a node where you do not have a mixture of 2 classes. It only has instances of no's. So there is a difference. What we call this kind of nodes is a pure node. When you have a pure node, you do not need a further condition, because then you can decide that if I have this condition loves counted greater than 3 And if the condition is not satisfied, I can clearly say that it's the person, these two persons have not enjoyed the movie. So the decision is taken, the final decision is taken right from this condition. Okay, so this looks good, right? So what is this kind of node called? It's called a pure node. In pure node, you do not have a mixture of multiple classes. You only have instances or observations of a single class. Okay, so the aim of decision tree is going to be to get to the point where you have nodes. Then if it is a node where you have taken a decision and it no longer doesn't no longer needs a split, it's not called a node, it's called a leaf. That is the ultimate level in that branch, right? There's a final level in that branch. So the decision tree's aim is going to be get to create pure nodes, okay, where you do not have mixture of multiple classes. Okay, now we can visually see that okay, we have got a pure node, but then there has to be something mathematical, because even this data is complex enough. You cannot do it visually, right? So there has to be a mathematical formula to find out whether a particular node has been reached, which is pure. Okay, so that mathematical formula is called Gini index, or there are two mathematical formulas that are taken. One is Gini index, one is entropy. So in today's example, we will go with Gini index and entropy. All right, so we will not go through a lot of theory now. Just understand that you have an input data set, and then the decision tree is going to iterate through a process to calculate the Gini index or entropy values, okay, to find out the pure nodes, right? And then choose the feature condition combination that results in the lowest Gini index. So what the decision tree is going to do is going to iteratively change this feature and change these conditions, and it needs to do it many number of times before it actually gets to the lowest Gini index. All right, so it'll iteratively keep on changing the condition and the features to come to the lowest Gini index or the lowest entropy value. Okay, so there is a mathematical formula towards that. And when it comes to the Gini index, lowest Gini index and entropy values by iterating, that is your condition. So that is the process that happens to determine the root node, and that process keeps on going on through your child nodes till you reach purity of the nodes. That is, you reach leaves. Yeah, that one thing you need to study is that there is a downside of this process. The downside is that in the quest to find pure nodes in large complex data sets, the decision tree is going to keep on building the tree until its last point. And that situation leads to overfitting. Okay, so to avoid overfitting, there is a process called pruning that is applied. We will not have time to go through all of that, but the pruning is required using a hyperparameter to control that overfitting condition that is natural to decision trees. Okay, all right, so we are not going to go through the calculation of Gini index or entropy. You can I mean, these are explained in our Code4X projects. You can go through that. Rather, we will go into the hands-on part. Okay. Okay, so I've got a question in the chat box. Is it like logistic regression? I mean, true or false? See, classification problems are solved in the same way. So ultimately, the outcome that you get from support vector machine or decision tree or random forest or logistic regression or naive Bayes, many classical algorithms that support solving of classification problems will give you the same result. Okay, but they internally work differently, right? So they internally work differently. Decision tree is a decision tree. Random forest is a combination of decision trees. Logistic regression uses the logit function. It's a mathematical function to get to the logistic equation, and then that creates a model between the target feature and the predictor features probability on based on probability. Support vector machine creates a differentiating or discriminating line between two different classes. It creates not a line, rather a path between two different classes, etc. So they have different methods: mathematical, statistical, probabilistic, etc. And the outcome from those, the accuracy that or performance that you get from each of these algorithms are also different. For different types of data, different machine learning algorithms work best. Okay, so a particular data set may be best applied to solve a problem, classification problem, by decision tree. But another kind of data set may need something like logistic regression to have the best results. So data science or machine learning is a lot of experimentation. When you go out in the industry, when you if you become a data scientist, you will see it's a lot of experimentation. So you have to experiment with multiple different algorithms and compare the performances and see that what algorithm is working best. And in Code4X also we are implementing that concept, is that a lot of our projects have multiple algorithms and the opportunity for you to compare the results of these multiple algorithms in one project, solve the same problem using multiple algorithms and compare the results, because that is what you are going to do in real life as well. Okay, but ultimately they are going to, classification algorithms will return true or false, 0 or 1, right? They can also be multi-class classification problems. So in that case, you may have 0, 1 and something else, or something other. All right. Okay. All right. So while I'm going through this code, you can also, or rather, before starting of the code, I want to show you something. I'll show you the Code4X website. So this is our website, and the site is dedicated to projects. So at this moment, we are building a large portfolio of data science projects. So we already have 6 projects that have gone live in the last 1 month, and these are the 6 projects. Some of these projects you will find as common and present in various other forums also, but of course we cannot, where it is an article in Medium or towards data science, we cannot um, give it to you in that form. So what you will have in Code4X project portfolio is that when you get into or purchase one of the projects, what you have is it's built up like a course. Okay, so Twitter sentiment analysis does not only, so if I go into this and if I show you the way it is structured, it's structured like a course. Okay, so you have a preview video, you have steps to be followed, you have input data explainer, what are the steps to be followed for cleaning tweets, and all of that. There is a lot of videos, so there is a huge amount of descriptive information explaining each of the concepts that are used in the project. Then you have it's supplemented by the videos. Entire concept and entire code are explained through videos. So everything is available there. It's very easy to follow. Step-by-step instructions are given everywhere. Codes are there. Data is given. Data links or data uploaded is given. You can use the code. Don't use the code right at the beginning, then you will not learn. But for your benefit, the codes are also given. So everything is given there. Within 7 days, you can master through this project in the learning by doing approach the entire concept of NLP data processing, and not entire concept, significantly NLP techniques for data processing, textual processing, or natural language processing, followed by how to ingest that data and implement a classification model using logistic regression algorithm. Okay, so it's very elaborate. Don't think that this project is just like any other Medium article or towards data science or analytics with the article. They are not. It's constructed like a full-fledged course. Okay, but the approach here is learning by doing. So I wanted to show you this before going on to our hands-on today. So Richa sent you a mail today, and she said that you can install either Anaconda Jupyter Notebook and also check whether these libraries are present. So you can, while I am executing the code, you can also execute the code on your laptop if you have Anaconda Jupyter Notebook. So I'm using Anaconda Jupyter Notebook, and you can use the same, or you can also use Google Colab to do this. So what I'm going to do is I'm going to copy this code snippets, and one by one I'm going to put it on the chat box. You can copy it and also run it along with me. Okay, so first of all, import all the libraries. So run the import libraries. So what are the libraries we have? We have NumPy array, we have pandas data frame, because typically for data processing, pandas library is extensively used for multi-dimensional numeric arrays. When we need it, we use NumPy array. Now, scikit-learn is a library in Python, a machine learning library in Python, which is very widely used. Okay, so scikit-learn has different modules. One such module is the datasets module. Okay, so what is the datasets module? The datasets module has a lot of datasets, pre-available datasets within the library itself that you can directly download. You don't have to download a file, a CSV file or something. Just to make it easy for you, I have used scikit-learn's datasets module, and there are some other module which are for beginners. You can use them for different learning purposes, classification problems. So let's say Boston house price predict house price dataset can be used to learn linear regression. IDs plant dataset can be used for classification, as well as image classification problems. So on and so forth. You can explore these datasets. It also has multiple other more industry-like large datasets. Okay, real life datasets. So these are toy datasets. It also scikit-learn also contain real life datasets. So you can go to scikit-learn and explore all these datasets. The other ones are typical. So as I go forward, I'll explain what they are used for. So we have train test split, decision tree, classifier, plot tree, because we are also going to visualize our decision tree, etc. Okay, confusion matrix is a base for classification matrices, and we will do that classification report. We will print the classification reports of various classification matrix as to how our model is performing. Okay, so the next one, so basically one of the first real steps in the exercise is importing the data set. Okay, so import the data set. It's a toy data set, so it'll import very quickly. So I have put the code in the chat box. You can run it. So I will run it also. Okay, so now what has happened is that DF is a data frame, pandas data frame that is created. So I will show you how you can type it in. I don't have to send you DF. And you can see that this is your training data set. So it has, so what I was saying is that for cancer detection, the input that you have is the diagnostic results. Okay, so these are the parameters or readings from various diagnostic results, or parameters that are extracted from the scan of the affected area, and these are the dimensions that are recorded. Okay, and with these dimensions or diagnostic results, we also have a classification. So this particular feature in the data set is our label or target feature or target variable. All right. So the other ones are, so this mean radius to your worst fractal dimension. All these are your predictor features, and the target is the target feature. Okay, or dependent variable. So independent variables and dependent variables. So this is how the input data looks like. Now you can type this in also. So this df.info will give you a bunch of information about your data. Okay, and it lists out all the features that you have in the data set, and it lists out how many not null or non-null instances that you have of these fields. Now, why do I care about these features? Because you see that there are, it says 569 entries. So how many rows that we have in this data set? 569 total number of rows and 31 columns. Okay, 30 predictor feature and one target feature, right? So it says 569 not null instances. So let's say, for instance, this particular field called concave points error. Okay, instead of 569, if this guy here said 541, what would that have meant? If instead of 569, one of these have had a number 541, missing values or null values, correct? Okay, so missing values or null values. So now you know why this is printed and why this number is important, because at a glance you can say that there is no non-null information here. So okay, so one respite, there is no not null values. In case of not null, you have to impute, or you have to delete those records. Okay, based on what is the situation. There can be different types of treatments that you can have. You can delete those records altogether. You can impute these values with a default value, etc. So there can be multiple different things that you can do. Okay, and it also shows you the data types. Okay, and from the data type, you can see that these are all fractional numbers, and your target value, which is going to be 0 or 1, is a. So you can execute this as well, and I will execute it as well. Okay, so here, what are we doing? We are doing we are taking a value counter for the target field in the data frame that we have. Okay, now what we are doing here is a check for class balancing, right? What is class balancing? Class balancing is a check to find out how many observations or records that you have belonging to each of the classes. Okay, so what are our classes? Our classes are zeros and ones. Okay, and those are there in the target field, right? Now here, this code has given me 357 of class 1 and 212 of class 2. I also have a visual representation of this same thing, which looks a bit more nicer. I'm giving the code to you on chat so you can execute and find out. So why do I need to do a class balance check? The class balance check is that if instead of 357 and 212, if we had a situation where instead of 357 I had 515, and instead of 212 in 0 I had 24. So 520 here and 24 here. Now that would be said, it's going to be said that it's a imbalanced data set. Now, is that a problem? Is imbalanced data set a problem? Anybody? Is imbalanced data set a problem? Yes, so imbalanced data set is a problem because if your one of your class is heavily dominant, that is the example that I was giving is 520 and 0 being 24. So your class 1 is a dominant, very dominant class in the input data set. So the machine learning algorithm, when it's using the data during its training, is going to favor the dominant class. And the output model is going to be such that most of the instances or test instances that you feed it, it is very likely to output 1 irrespective of its actual merit. Okay, so dominant class will create a that class dominant model. Okay, and it is not going to be accurate. So here in this case, we are doing a class balance check, and you have to make sure your input data is perfectly balanced. I mean, not perfectly balanced, but it does not have a huge difference. Okay, it should not be 10% and 90% or 20%, even 20%, 80% is also a problem. About 60, 40, 65, 35 till that point, it is okay. Otherwise, it is going to go towards tilting towards a dominant class. So you need to do a class balance check. Okay, so your class balance check is done. Then you are going to do a test train split. Why do I need to do a test train split? Data is the god of machine learning. Okay, and most often data is not available. You will find this situation in industry. Okay, so like in traditional programming, your input is the rule, data is a input to your machine learning programming. Okay, so the data that we have got, we need to segment it in a training data set and a test data set. Normally, we create a segment of 70% for training and 30% for test, or 80-20 is also fine. So there is this scikit-learn module called test train split, which is going to take the input data set and it is going to split it. So you have to give the test size, which is 0.2. So meaning that 20% of the input you set aside for testing, and then give me the rest. Okay. Now here, see, one thing is that in a lot of programming language, you have seen that there are functions that return values. Okay. And most languages, a lot of languages, and it's changing nowadays, a lot of languages return only one value. Python is beautiful, and Python can return n number of values from one function. Okay, so here is this test train split function. It typically returns these 4 values: x train, x test, y train, y test. What is your x and what is your y? X is the set of predictor features. Okay, in our case, it's all the diagnostic readings of the patient that are the predictor feature. And what is y? Y is the target field, your label, 0 or 1. So that is the target. So what it is doing is it is splitting up the input data and it is creating a set. So 80% of all the predictor features will be in X train. 20% of all predictor features are going to be in X test. 20% of all predictor features will be in Y train. Sorry, 80% of all predictor Y train. Sorry, 80% of all target features, or there is only one target feature, is going to be in Y train, and 20% of all target feature is going to be in Y test. Okay, so that is the split this guy is going to do. Okay, so you can test it and we will see X train has got 455 rows. Y train, how many rows Y train is going to have? Same, correct. So X train and Y train, so it's the same data set, predictor and target. right? So they should have the same matching number of records. Okay, so if X train has 455 records, then Y train will also have 455 records. So we see Y train run, and there are 455 records. Okay, and X test 114, and Y test will have also how many? Y test 114. Okay, so I displayed this just because we wanted to check whether the data is fine, and they have the number of rows that we are expecting, and they are looking like what they are expected to look like. Okay, so our exercise is a toy exercise, but is a real exercise. What we are going to do now is we are going to create our decision tree classifier. So all those jing bang about creating the trees, inverted trees of decision and nodes, you don't have to do. Your decision tree classifier from scikit-learn is going to do all the calculation iteratively and present you with a perfect decision tree. Okay, so that's what we are going to do now. Create your classifier, X-train classifier. So there it's two steps. One is creating the decision tree classifier object, and the second step, which is the model name dot fit. Okay, so this is creating the model, and this fit is going to train the model. Okay, so if you have a very large data set, I mean, in this case, we have a very small data set. But in case you have a large data set, let's say, for instance, 1 million records, then the decision tree is and you are running it on your laptop, then this guy is going to take a while. I mean, maybe up to a few minutes based on the power of your computer. It may take a few minutes to fully train the model. Okay, so now what we have got? We have got our model. What is the name of the model? Anyone? What is the name of the model? CLF. Yes, correct. So CLF is the name of the model. So we have got our model now, right? So then what is the next thing that we should do when we have got our model? What is the next thing that we should do? We should find out our the performance of that model. Okay, so let's find out the performance of the model. Okay, so it's giving a sorry. Okay, so I did not execute the training, and here is a code that you have. Now what we are going to do is we are going to do a prediction. We have got a model. Now we are going to do a prediction. Now for prediction, what are we going to use? We are going to use our test data. All right, so we are going to use the test data because we have trained the model using the training data, and we are going to use the test data for prediction. Could we have taken the test data for our prediction as well? Could we have taken our test data for prediction as well? No, because the training data is already seen by the model. So very likely it is going to give you the correct answer. You have created a model and you want to see whether your model is able to correctly predict the decision, that is 0 or 1, has cancer or not, no cancer, whether it is able to predict accurately with data that it has not seen. That is why we set aside the test data separately. Training data should not be used for testing, because then it's very likely to give you the correct answer, and that's not a test. It's like telling the answer or the giving the question paper to a kid before his or her exam, right? Okay, so then we are going to, where are we? Then that's training accuracy. We are going to test next. Have I given you the, let me run the testing, and the testing is done. Now we will see the results. Right, so what we have done is here is that we have printed the actual values and the predicted values. Okay, visually this is the best way to figure out where it is going wrong and where it is coming right. So your predicted values are stored in ypred. Okay, so that's another array that we have created, and that's stored in is the predicted results from the predict function using the xtest feature set or the xtest data set. These are the predicted values. And what is the original values? The original values are stored in ytest, which came from our data set, right? Where was it? So ytest. So in the testing set, we have provided ytrain to the predict function, and we have set aside ytest, and we have got ypred from our prediction. And what we are doing now is that with this data frame, we are creating this data frame with actual and predicted labels using ytest and ypred. Okay, so here is the comparison, and you see that actual and predicted values in all the cases are correct. Okay, and these are 114 rows. So 114 is a number of rows that we have set aside in our test data set, right? So they all look to be the same. Now this does not satisfy us. We need to see there must be some mistakes that this guy has made, right? So we want to see where all it has gone wrong. So here is another trick that we have played, and we have said that, okay, give me all those instances where they have not been correct. Okay, so here are these 6 examples or 7 examples or 6 examples where I have to give you the code. Which codes I have to give you? This code I have to give you, and then this one as well. Okay, so run them. This code puts in this condition when the actual value is not equals to predicted value. Okay, so we have taken both of these variables in one data frame. So this is what it is, comparison df, and we have printed only those ones. We have actually created another data frame containing the unmatched records. So these are the ones. Okay, so that makes it clear that in some cases it has also gone wrong. Okay, and you can actually then, so this kind of diagnostic will come in help of the ultimate or final user. So let's say if a doctor is using this model, and these are the cases where your model has gone wrong, it is important for the doctor to know, okay, which of my cases have gone wrong. Let me see the records, let me see the diagnostic results, and let me see how they have not been predicted correctly. Okay, so it is important for the final user or the end user of your model to understand where the differences are. Okay, so we do a little fancy trick to create the confusion matrix from our test. Normally you can print the confusion matrix in a pretty straightforward way, but here we have decided to do it a little fashionable, and this is the code. So it's a matplotlib library code. Matplotlib is a combination of matplotlib and seaborn. Seaborn visualization library is also built on top of matplotlib, so the raw features are from matplotlib, and then certain styles and etc. are extracted through seaborn library. Okay, right. So here's your confusion matrix. For classification algorithm, it's a must to understand the confusion matrix. Okay, along the x-axis you have predicted values, and along the y-axis you have the original values, actual values. Okay, now I want to show you the target names, the malignant and benign. Okay, now where did this come from? You will see the original code where the code at the top where Escalon dataset was downloaded. Yeah, all right. So here data contain the predictor features, target contain the labels. Okay, and from there is an attribute called target names in the data set from scikit-learn, which stores the corresponding labels or names for the 0 and 1. Okay, so malignant and benign. So malignant is 1 and benign is 0. That's how it has to be interpreted. So 1 is positive, 0 is negative. So malignant equals to positive equals to 1, benign is negative equals to 0. Okay, so that's how it has to be predicted. And these 4 quadrants of confusion matrix give you 4 figures. Okay, I'm not going to explain which is which one. It's going to take a bit of time. It gives you false positive, sorry, true positives, true negatives, false positives, and false negatives. So do a little bit of study and find out from the confusion matrix which is which one. Which quadrant is false positive, which quadrant is false negative, which quadrant is true positive, and which quadrant is true negative. Okay, so these are the 4 values that we are working with. And then we also print the classification report, and that is an exhaustive list of classification matrix values from your classification model from the testing that you have conducted. So we execute it, we'll get a bunch of figures. Okay, so first of all, your eye is going to be on the accuracy level. So our testing is achieving an accuracy level of 95%. Okay, but there are other classification matrix that are important to you, right? There is a video that I'm making and putting it into all the classification projects in Code4X for explanation. They're already explained in textual format, but additional video is going to be included in all the classification projects. And those will explain what is precision, what is recall, when precision matrix is used, when recall matrix is used, because classification algorithm is incomplete, a classification project is incomplete without understanding the precision and recall performance of your model. Okay, so if we do a little bit of explainer here, precision for malignant, okay, the precision value for malignant, which is 95%, it means out of all the instances that were predicted as malignant, 95% were actually malignant. Okay, so I mean, you have to read it a couple of times to actually make the meaning of it. Out of all the instances that were predicted as malignant, 95% of actually malignant. On the other hand, if you recall, if you go to recall and try to interpret the recall value, where is the recall value? Recall value for malignant, it stays out of all the actual malignant instances, 91% were correctly predicted as malignant. Okay. Out of all the actual malignant instances, 91% were predicted as malignant. Now, here if you try to make meaning of this line, you will come to realize that it's a dangerous situation. So there are 9% of the cases in our model, in this case, which were, all right. So yeah, what was the dangerous part? So 9% of the cases that were there, which were malignant, actually malignant as per our test data, but they were predicted as non-malignant, right? So you see, in this particular classification use case, having a recall value of less than 100% is actually very dangerous. Then even if it is 1%, that 1% is being considered as non-malignant, so non-cancer case, while this person was having cancer, right? So for this particular type of cases, your key criteria or key metric that you should optimize your model on is going to be your recall value, right? You should achieve to or aim to achieve 100% recall value. Okay, so that's how this some of these matrices are interpreted. We will also do one other interesting thing, which is printing the decision tree. Okay, here is a code. You can do it as well. And if you see, there is a perfect visualization. It's not very legible. I also struggle to read. It's so small. This can be adjusted by uh, tweaking a few parameters of the graph, but they are small because probably because there are so many number of leaves in here. Okay, so there is a tree. Now there are multiple information, a lot of information that you have here. Each of the nodes have the condition. So when we explain decision tree, we have said that decision tree is a inverted tree of conditions. Okay, so all these conditions were created by your decision tree algorithm, scikit-learn decision tree algorithm, and all these conditions are actually mentioned in visually in the decision tree, visualized decision tree. Okay, you also have the Gini index. Okay, we said that to come to the perfect condition for a particular node, the Gini index is calculated for various randomly picked features and conditions, and the condition that has the minimum Gini index is taken. Okay, to be the condition for that particular node. So the Gini values, Gini index values are given. How many samples you have? So 444, 455 samples are given. How many the split of yes and no's in that 455 samples, etc. All those are given. So for each of the nodes, you have this information, the condition, the Gini value, the number of samples in that particular node, and the split of yes and no's. All this information are given. So one particular feature, one very important feature of decision tree algorithms, because of which it's also very popular, is that it is interpretable. Okay, why it is interpretable? Because you can actually visualize the decision tree as we visualize them in the images that we create in for our learning, right? So exactly same way the visualization is possible for decision tree. So you can exactly find out for a particular observation that you feed in your testing step, why it has been classified as 0 or 1. You can look at those values in the features, and you can visually traverse through the decision tree and find out which of the nodes this particular instance is traversing through, and finally coming to the decision of yes or no. So this characteristic is called interpretable. Okay, so which kind of machine learning algorithms are not interpretable? Most notorious are the deep learning algorithms. So they have so many millions of parameters. They have multiple different layers. The layers itself themselves are very complex. There is forward propagation, there is backward propagation of information. Hence it's absolutely I mean, most of the machine learning, sorry, deep learning algorithms are absolutely uninterpretable. So if you get a decision from a deep learning architecture, it is almost impossible to say why that decision has been taken by the model. Okay, so interpretability nowadays is a important criteria because of AI ethics and all those concepts coming up that we have to comply to. All right, so that's more or less it. Did I give you the code for the decision tree? Plot the decision tree? Yes. Last is basically a simple example of you can take one data point and do a singleton testing to see what value is being returned. So the observation that we are passing into this particular test feature, it's coming up as benign. So you can do this testing also in your notebook. Okay, so there lies our. We have overshoot the time, but I hope this session has been informative to you. Yeah, so if you go to our all projects page, you can see my screen, right?
Yes.
Yeah, there is a simple project called student dropout prediction. Now it's a simple project. The way it is explained, again, it's like a course, and you get to learn a lot of things. This particular project has, as I said, the life of machine learning professionals or data science professional is full of experimentation and comparison experimentation with multiple different algorithms. So here is a project where we have used two very popular machine learning algorithms. One is decision tree itself and naive Bayes. So you get to learn naive Bayes, you get to learn decision tree, and you get to do the project using naive Bayes and decision tree, and then finally compare the results and see which algorithm is giving you the best results. Right. Similarly, if I go back and show another project, there is predictive maintenance of machines. This is another project where we have logistic regression, random forest, and support vector machine. They are all very powerful algorithms, very powerful classical machine learning algorithms. And this particular use case, predictive maintenance of machines using machine learning. So you get to do this using this three algorithms and compare the results and evaluate the results. Okay. If you want to learn about time series forecasting, you can have the stock price prediction project where it teaches about a particular, the most popular time series algorithm called ARIMA. Okay, the ARIMA algorithm, autoregressive integrated moving average. So that's used for time series forecasting, and our use case for this project is stock price prediction. If you want to get introduced to deep learning and the image classification, you can do this project, image classification using CNN with Streamlit deployment. So this one has two interesting aspects. One is it's introducing you to deep learning using convolutional neural network, and it also has Streamlit deployment. So you get to create an UI with the Streamlit library at the end. So it's full of videos, full of explanations, and etc. Okay, so it's modeled like a course, and it's everything around executing this project is explained in detail, both in textual format as well as in the video format. Code is code and data, etc. Everything is provided to you. Streamlit deployment, everything is explained. Deployment part is explained. Your UI is tested, and there is a video as well of the explanations. If somebody is interested in analytics as well, you can have this project. So this is a very powerful project. We've taken a data set. It's a fairly large data set of red cat shoes US. It's fictitious, but the data set is powerful. The analysis that we have done in using the red cat data is also very powerful. It's not a common project. You will hardly find this anywhere. I haven't seen it. It's built by our team. The entire analytics is built by our team. There is a whole bit of pre understanding about analytics and domain, and then going forward, there is a significant analytics part using SQL, and there is a significant analytics part using Python as well. Okay, so this project is like a full-fledged analytics course by itself. All right, okay, guys. Thank you for being here today and being so attentive and following the session. I hope it was useful. Thank you all.